We've been talking about object-oriented programming, and we've been talking about how to create objects. And one of the questions on the quiz was, what is inheritance? And many of you got this very, very correct. And it is a way to reuse code by inheriting behavior from a supertype. Okay. The nice thing is that this behavior doesn't need to be redefined. You just need to add any additional state or behavior that you want to it and alter what exists as you need to. So if you want to overwrite behavior in a supertype, all you have to do is redeclare a method like you did in the original supertype class, and then just give it the new behavior. So this is why the dunder init works the way it does. If we come here to credit card, we've redefined our init, and this does what you think, right? This does exactly what we said, but you're actually redefining a method of a superclass when you do this, because remember that there is a default superclass that credit card inherits from. And you can see this if you say class, we'll just call it obj pass. Okay. And we'll say O1 equals obj okay. O1 dot dunder init. Look at that. We didn't define anything in obj, but our dunder init exists there. So this shows you specifically that that thing already exists. So this is a method of method overriding. This is how you override a method, by just declare a method that already exists, give it the parameters you want, and just make it do what you want. Does this make sense? We vibing on this? Yes? No? Cool. What if, well, we'll get to that in a moment, right? You conceptually, we can also think of the subclass as a more specific version of the base class. So a football and a baseball are more specific versions of the concept ball. You can imagine how both of them are related to the idea of ball, but they're significantly different in many, many ways. But the inherent ballness of each of them is still present. So this is what inheritance means conceptually at an abstraction level. So here I'm about to tell a fib. Objects can only inherit from one base class, and this is not true. This is not actually true. Objects really should only inherit from one base class. And there's a reason. And it goes very simply. I have my object. And I have, let's say we go with our, we have credit card. And we have our cash. Right? And we want something that's going to operate like both of those. All right? Well, this one has a make payment. And this one has a make payment. Cash having a make payment doesn't really make a whole lot of sense, but On a conceptual level, you can see where I'm going with this. Okay, let's pretend debit inherits from both of these. Which of these two methods does it inherit? Does it get the credit or does it get the cash? Can we see how this becomes a structural issue, a big concern? Do we have questions on why this? So some languages have this, some languages don't. I was raised in the cult of Java. That was my first learning language, like really learning language at a deep level that I was being taught by someone else. And in Java, you cannot do this. They're just like, nah, don't do that. It will break if you try to do it. And people who are brought up in that cult think that Java is the way, capital T, capital W. So it was only a couple of years ago that I learned that Python actually does allow multiple inheritance. And then the moment I got told that, I think it was either Professor Chu or Professor Rumbaugh who brought it up to me, said, but don't do it. And I went, okay. I mean, I wasn't planning on, but why? And they pointed this out to me. They're like, there's all sorts of issues. And how do you define it? And how do you do it? No one that I've spoken to has ever seen multiple inheritance done in a way, in a place that is not simply a classroom setting, right? Hey, you can do this, and here's how you do it. That's the only time anyone's ever seen it used. So, inheritance. If we have an example, this is an actual live real example, right? We have the Python base exception. Every exception, every kind of broken thing is one of these. System exit, exception, keyboard interrupt are all direct subtypes of base exception. Hey, do you guys know how to do it? Have you guys ever seen a keyboard interrupt? Do you know what that is? Control C. Very good. You hit Control C, you get a keyboard interrupt. While true. Yes. Uh-oh, things are broken. Keyboard interrupt. Everything's fine again. Okay, that's an actual exception. So coming back to this, in the exception type, we have all sorts of other exceptions, and there are tons. You can look them up. But notice that, like, hey, anytime I'm looking up data and I get an error, I'm going to get a lookup error. So index errors, hey, I've given an index that's out of bounds. That's a lookup error, as is a key error. Hey, I want to look up this thing in the dictionary, but the key doesn't exist. Okay, these are both subtypes of lookup error. Versus zero division error is a kind of arithmetic error, right? You can see as we go down, we get more and more specific. And maybe this one would have a list index error versus a, I don't know, tuple index error. I don't know why you would have that difference, but if there was a meaningful difference to it, you could. And you could just keep going down and down the tree, right? Turtles all the way down. We feeling this? We're getting this? Is this making some sense? Understanding how to leverage this successfully is going to be key to completing Lab 1 in a way that you don't want to throw yourself off a bridge. Because Lab 1 has a lot of method calls, right? And we're going to get into this. We're going to get into how to design a class right now that keeps certain aspects of behavior. So let's suppose we want to keep some aspect of the base class, but kind of tweak it, right? If I throw a baseball versus throwing a football, they're kind of the same, right? So the throw method might involve similar things, but not the same things. If I wanted to call a method from the superclass, how would I do this? Anyone know? What is going on? This looking familiar? The super keyword? Super underscore method name list of arguments. Okay. Does this look familiar to anyone? Okay. Where is a good place to use this? Yes. The question was, isn't calling super differently in different languages? And the answer is yes, it is. This is not, remember, what we are teaching you here is Python syntax. And so different languages will have different syntax and may not have the same behaviors and aspects available to it. But yes, calling super in different languages is different. In fact, it gets me every time because in most languages it's not a function call. In most languages, you just say super dot and it's a keyword. I'm going to give you this hint. This is a great thing to do in subclasses of constructors. Super dot init and then arguments to pass in. You don't want to redefine your instance variables in subclasses. Okay? The superclass already has that information. You don't need to redefine it. You only need to define new instance variables. So anything that you haven't stored before. Everything else, you say, you know what? I'm lazy. I don't want to write it myself. You handle this. Okay. So let's do an example. And I think that this is going to make some more sense when we do an example. We are going to do a chipped credit card, like the new ones that you put into the machines and they read it and it takes a minute, and then when they're done, the machine goes and it yells at you, even though it should just say, hey, could you take your card back? Those things, right? Versus the old school swipity kind. So we're going to create a chipped credit card, and we have our credit card here if we need to. Remember, we need to bring this object into this file. So what's the very first thing we're going to need to call in this in this chipped credit card object? What's the very first line of code we're going to need to write? And I'm going to give you a clue. One of the keywords starts with an I. I'll even give you IM. What are we looking to do here? Import, right? Now, I always get the syntax wrong. I always want to say import the object from the file. And I think that's my C#. And we are section 01, but it's actually the other way around. Every time I do this, it's from file import object. Cool. And then we're going to give our class the name, right? And we want this to extend the credit card. So how do we say that? How do we say extend the credit card? How do we say we want to make this a subclass of the credit card object? And I would encourage strongly participation, because the longer we take to go over this stuff, the less time we're going to have to work on the actual lab. So if you want to have time to work on the lab with some help, it's going to be helpful to get through this. How do we say, I want chip credit card to extend to implement as a subtype credit card? Okay, so extends, that's a great guess, but that's Java and that's C#. Actually, I think extends is Java. I think colon is C#. Are we allowed to have parentheses at the end of this line? Okay. What purpose do they serve? No, we don't give parameters to the class definition. Why could I possibly be asking this specific question right now? That is how you specify it. Parentheses at the end of the line. And to give you an idea that this works as is, we're going to run this. And we're going to fix something in the main class. Oh, what did I get wrong here? Oh, I do this every single time. I am the king of forgetting a colon at the end of an if statement. So, 2 from the top, 5, 6, 7, 8, and it runs. And we can say CC1 equals chipped credit card and give it things like Brian, the bank. Notice that the pop-up is suggesting parameters as per the regular credit card. What did I miss there? Oh, I missed a comma. As per the regular credit card, right? And when I call the constructor properly, it works. Let me shrink that a little bit so it's a little higher on the screen. So cc1.get balance, it works. cc1.get bank is there. All of these methods are already there because they've been inherited from credit card, as is the instance variables that back it. Okay. But we're going to want to redefine some of this stuff. We're going to want to add some more data to this. Okay. Let's say that we still want to get, when we define our chip credit card, we still want to get our customer. We still want to get our bank. We still want to get an account number. Let's say we don't want to get a limit. Let's just say, for fun, that the limit for one of these is always $5,000 because the security is higher. But we also want to get a chip type. That's going to be a thing. And the CCV, there's a number on the back for additional security. Okay. We following so far? Okay. So, step 1 is we know that we're going to want to use the superclass constructor, right? And as we see in the underlying slide deck, this is how we call the superclass constructor. So let's do that. Super dot init, and it helps if you give it the actual name of the method, and put the dot there. Man, I've either had too much or not enough coffee so far today. Okay. What's the first parameter this thing expects? Customer, okay? Good. Because it's what's defined over here. Customer is expected, then bank, then account. Hey, what do we want to do for a limit? We don't have a limit parameter. What do we want to do a limit for these guys? Why do you say less than 5,000? Oh, I see. You're saying that you want to limit it at 5,000. You want their balance to be less than 5,000. Yeah, okay. Well, so the limit does the less than or equal to part. We can see that over here, right? Less than or equal to the limit. We just need a value for the limit. So we can, and we can just say, you know what? Take 5,000. Right? Are we starting to see how this can work for us? Now what do we need to define in here? What instance variables do we need to define? What instance variables do we not get from our superclass? No, charge is not, first of all, charge is not an instance variable. Charge is a method. Right? These are all methods down here. $5,000, look, we're going to call this. Customer is going to get mapped to customer. Bank's going to get mapped to bank. Account's going to get mapped to account. 5,000 is going to get mapped to limit, which is going to get stored in limit here. So the 5,000 is going to get stored in the limit. What instance variables, I'm sorry, what parameters up here do we not have instance variables to store for? Yeah, chip type in the CCV. So we can say self dot underscore chip type equals chip type, and self dot underscore CCV equals CCV, right? And then we can come and define a couple of instance methods that are going to make our life quick and easy. And let's say that this kind of card gets a little bit of a benefit from the bank because of the increased security. And it gives you a 1% discount on purchases. What method from the superclass deals with purchases? charge. So we're going to redefine charge. We're still going to take a price, right? Because we need to do that. Hey, what if we wanted to do this, but just with price as 1% less? How can we do that? Quick and easy. I mean, we could, if we wanted to, take and copy this and paste that here, and then do parentheses 0.99 times, right? We could do this. But now if our behavior changes in one, we're going to have to change it in both. So I'm looking for something that you can do in a single line of code that's going to weaponize this behavior in a way, use super for charge, beautiful, in a way that minimizes your effort. Oh, Dad, yes. I'm stealing the code from the text box. Okay? Except we need to do one more thing. Right? Now we pass in the smaller value. Right? And that'll work. And we can just return the value that's, this thing is going to then call this thing. It's going to return either the balance or -1. It's going to turn this into the balance or -1, and it gets returned. Are we seeing how this works? Do we feel good about this? Get balance. CC1.charge 100. Hey, it returns 99. Get balance. Make payment 100. Oh. What did I do wrong? Oh, I still have that garbage in there. That was the example that we ran to show the difference in parameters. So I can rerun this. Do that. Do that. See that that's true. Get a -1. Oh, are we still getting it? Oh, I didn't rerun this. There we go. The problem with doing things on the cutting edge. What am I not doing? What am I missing here? Oh, I also have that in there. Well, you see what I'm trying to do. Yeah, thank you. From the top. One more time. And if this doesn't work, we're going to say the example doesn't need to be done. There we go. Hey, that didn't work. Get balance till 99. Oh, crap. Well, let me pay off 95. Get balance is now 4. CC1.get chip. It's an RFID chip.